All right, we can get started. So I'm going to introduce our presenters from CK Delta. We have Porik Karan, data scientist, and Nayan Sharma, lead data engineer.
So we have the usual prerequisite slides before we start. This is the forward-looking statement. This just means that this is for educational and informational purposes. We're not making any guarantees or commitments, and it's just forward-looking statements. As well, a reminder to complete the survey after the session. You can find it under the session content, and then you go to My Surveys, and you can say what you like, what you don't like, and this helps improve the summit for next year. So let's jump into the heart of our presentation, real-time monitoring of IoT smart meters and how we're enhancing energy insights through continuous data collection and analysis. I'm Porik Karan, data scientist at CK Delta, and with me is Nayan Sharma, lead data engineer at CK Delta. Together we're excited to share the work we're done using Databricks and Azure to unlock real-time intelligence, using Databricks and Azure to unlock real-time intelligence across millions of connected devices. Our project is focused on smart meters, the digital sensors installed in homes and businesses that track electricity consumption throughout the day. These meters generate massive amounts of data, but the challenge is more than just handling the scale. It's about transforming that data into insight quickly enough to act on it. So here's a quick look at the agenda that we'll explore today. So we'll start off with a short introduction to CK Delta, who we are and what we're doing and what we're working in this space. Then we'll dive into the business context, the scale of the smart meter estate that we're monitoring, and the kinds of operational challenges our utility partners face when these devices get disconnected and go offline. From there, we'll break down the technical solution, how we built an event-driven pipeline using Databricks, Azure Logic Apps, and push APIs, and how we ingested and transformed streaming data at scale with Databricks and the Lakehouse architecture. And then finally, how we brought this all together through AI, BI dashboards and deliver real-time insights to our customers. We'll wrap up with a few key takeaways, what worked well, lessons learned, and the broader potential of this architecture beyond energy analytics. So let's begin by telling you a bit about CK Delta. So CK Delta is a data and AI company within the CK Hutchinson Holdings Group, a multinational conglomerate with interest in everything from telecoms to ports to utilities. We were founded in 2018. We've headquarters in Dublin, Ireland, and we have offices throughout Europe and Asia. Our mission is to build intelligent data applications that drive measurable impact across CK Hutchinson's global businesses and our external customers. We work in sectors like logistics, retail, utilities, and infrastructure. And we use data science, machine learning, and modern engineering practices to solve complex and operational problems. In this project that we're speaking about today, our focus is on utilities, specifically electricity, where we're helping deliver real-time insights from millions of smart meter deployed across homes and businesses in Ireland. So now that you know who we are, let's introduce our team. So my name is Porik Karan. I'm from Dublin, Ireland. Very excited to be here in San Francisco. For those live in the room, can see I'm a brighter shade of red than I should be. So we had the opportunity to arrive a few days early, and we were exploring your beautiful city. And I got a nice tan and sunburn on some tours across your city. So I started my career in mechanical engineering, working in offshore oil and gas, designing off-field structures using finite element analysis. Also did some work on research in wave and tidal energy. In 2013, I decided to make the switch to software and eventually AI, excited by the research that was happening at the time in AI, specifically deep learning wasn't as popular back then, and neural networks weren't cool as they are now. So it was an exciting time to join. When I'm not wrangling data in CK Delta, I like playing with tech at home. I'm a blockchain enthusiast. I used to invest in Lego and trade Lego, but then I got involved in crypto because it collects less dust and easier to store. But with that, I'll hand you over to Nayan to introduce himself.
Yeah, thank you, Porik. Good evening, everyone. I am Nayan Sharma, lead data engineer at CK Delta. I have been working in big data space since 2012. And I worked on multiple tools like Talent, Informatica, Databricks, and multiple cloud technologies like AWS, Azure. Then what I decided that let's transition my career into data analytics. So I pursued my master's in Ireland, Dublin. Why I did it? Because I love to play with data. I love to convert this raw data into the business use case and business insight. So that is where I transitioned my career. And I'm also a big fan of agile and data visualization. On some of the projects, we have built the live AI dashboard that become the go-to tool for the decision makers. That is where I think analytics really shine. And I'm not lying anything about my profile. You can visit my profile on LinkedIn and you can verify all these things. But yeah, Porik and I together worked on this project from the beginning. So we are really excited to share our story with you. And we'll go through the challenges and the solution that we put in together for the customer. So we can go through the overview.
Yeah, so let's take a look at the core challenge we're facing before we dive into the deeper technical details. So the problem that our clients brought to us was clear. How do we get real-time visibility into the status of millions of smart meters and quickly identify which ones are offline, malfunctioning, or failing to report usage? This may sound simple, but when you're talking about a national rollout of IoT devices, data volume, latency, and reliability challenges become very real. In the next few slides, we'll unpack exactly what makes this a difficult problem and why we needed a robust scalable analytics platform like Databricks to solve it. So here's the real-world scenario we were tackling. This project was for ESB, the Electricity Supply Board in Ireland, and 3R Ireland, who supplied the mobile network connectivity for the smart meters. At the moment, there are about 2 million smart meters deployed across the country. The final plans have 2.8 million in total, each installed in a home or business, and they report the consumption every 30 minutes via the mobile network. Now, the challenge is that many of these meters can and do go offline. So our goal was to build a solution that enabled real-time monitoring of connectivity of the smart meters. Our first reaction was this was an easy problem to solve. We can develop a notebook to poll each smart meter and poll each one every hour. But the problem was, the challenge was that the IoT platform that the ESB and 3 Ireland are using, Cisco Jasper, only allows 5 requests or transactions per second. So this means that we couldn't provide the data in real time. So the solution to this problem is that the IoT platform also provides a push API. So we decided to use this and monitor by exception. This means instead of scanning all the meters, we needed to be notified about the ones that were failing. So on average, ESB are seeing around 40,000 of the smart meters. We're generating disconnection requests daily and about 210,000 cumulative per day. So that's a massive amount of volume to track and diagnose in real time. So our solution, which we'll show in the next few slides, allowed them to spot the patterns in connectivity, short-term outages, and more long-term connectivity issues and get to the bottom of those. And we were able to deliver, and with this, they're able to deliver better customer support and help to respond quickly to service and billing issues. So now that we've seen the scale of the challenge, let's walk through how we solved it.
Yeah, so here is the high-level view of the technologies that we use that enable us to do the real-time smart meter monitoring. So basically, you can see that it is a combination of Azure and Databricks. At the top of the pipeline, we use Azure Logic App that receive event directly from the push API, and it helps us to act on the data as soon as it arrives into the system without, we are not doing pooling and the batching. So from there, everything flows into the Databricks Lakehouse, which gives a single platform for both and streaming analytics, simplify our data architecture dramatically. We surface the result using the AI/BI dashboard, which is now very famous, and everyone is using it. So we'll show you that how we have used it. And then you can see that we use Unity Catalog and the Databricks Asset Bundle. So Unity Catalog is mainly for the governance and the security purpose, and this is mainly where our data management stage or layer lies And asset bundle, I think everyone is aware that how it will be helpful to deploy your asset into different environments. So this help us to build a robust and scalable solution. So I think in future slide, we'll deep down into all these technical details. And now we can move to the next slide, which is basically the overview of the solution. Warwick?
Yeah, so here's a teaser of the final solution. It's a live Databricks dashboard showing the real-time smart meters across the country. This view in Databricks we use for internal usage, but it also mirrors the solution that the customers at ESB and 3 Ireland can see. So on the left, you can see we have the total number of disconnected devices. It's updated continuously in real time. So we have a live view of the data, and we also store the data so we can do historical trends. And we see all the other data. Rate plan, for example, is delivered by the push API. And we can then also break it down by how long ago the smart meter was disconnected. So with that, I'll go into the more details on the smart meter and IoT infrastructure. So what is a smart meter? On the left, we see the standard electrical meter. It measures electricity consumption. So a technician has to come every 1 to 2 months and read this manually and provide the reading to the utility provider. So there's no real-time visibility. On the right, we have the smart meter. This takes a reading every 30 minutes, and it's transmitted automatically over the mobile network via IoT using the SIM card from the mobile network provider. This is a huge leap forward, so it allows dynamic pricing through smart tariffs. It gives the customer real-time insights into their energy usage, and for the utility, opens up a wealth of live informational data. Of course, when you scale this to millions of meters and they start dropping offline or misreporting, the analytics challenge become less about collecting data, more about reacting to it in real time. So let's take a closer look at the ecosystem that lies behind this. So how does this actually all work? Here's a simplified view of the smart meter infrastructure that powers the system. On the far left, we have the electricity network, providing electricity to a home that has a smart meter. The smart meter is recording the data and submitting it every 30 minutes. That's then transmitted using a SIM card over the mobile network, in this case, 3 Ireland. And through the IoT connectivity with the IoT platform, it collects this data, and including activation, diagnostics, and metadata. And this is managed through the IoT control center platform. But of course, things don't always work perfectly, and that's where our challenge begins. So let's take a look at what can go wrong. Here's where the real-world issues start to emerge. Smart meters can, and they often do, miss emitting their readings. One reason is simply loss of power. This can be a scheduled maintenance, or it can be an unplanned power outage, or even something more extreme like a storm. Then the meter goes offline, and with that, the data stream disappears. As shown in the diagram, this breaks the flow of data right at the source. Smart meter in the house or building has no power, so there's nothing to transmit through the IoT connectivity or the mobile network. To give you a sense of impact power outages can have, let's look at a real example. So while we're developing this project in January 2025, Ireland was hit by Storm Éowyn, a once-in-a-generation weather event. It set the all-time wind speed record for Ireland, 113 miles per hour, or 183 kilometers per hour for those in the metric system. The result, over 750,000 customers lost power. That's 1/3 of all homes and businesses across the country. So events like this are a stark reminder of how vulnerable infrastructure can be, and how critical it is to have real-time visibility when disruptions occur at this scale. With a robust monitoring solution, utilities can quickly pinpoint which meters are down, which areas are worst affected, and where resources should be deployed first. This storm drove home the need for what we were building. So before we move on, here's a quick moment of levity. We'll dial down the seriousness. If it weren't for electricity, we'd all be watching television by candlelight. That's George Gobel, the American comedian. And while it's a humorous take, it's also a reminder of how deeply we rely on consistent, invisible infrastructure like electricity, and how quickly we notice when it disappears. And that's exactly what our smart meter monitoring solution is here to address, helping providers keep the lights on, literally. Here's what the aftermath of Storm Eowyn looked like from the data. So what we're seeing here is the daily count of smart meters with no connectivity. So devices that weren't reporting back to the IoT platform. So we can see we saw up to 500,000 devices during the peak of the storm. And then in the following days, we see as the bar charts reduce as the houses are coming back online. So this shows the value of real-time monitoring, not just during an event like this, but in the days after. We need to know which meters are offline and which regions are recovering slower. Of course, the repair crews use other systems for an outage of this scale, but our data is still useful for other teams to observe which smart meters are offline. And as we'll show, our Databricks-based solution made it possible to track all of this live as it happened. So far, we see now power outages can bring smart meters offline, but there's another critical point of failure, mobile connectivity. In some cases, the smart meter has power and is functioning normally, but it simply can't transmit its data because the mobile signal is too weak. This is especially common in remote or rural areas where coverage can be patchy or where signal strength is degraded by terrain, distance, or even weather conditions. In this scenario, the IoT data is generated, but it never leaves the device because it can't reach the mobile network. As shown in the diagram, this disruption happens after the meter, but it can't hit the IoT platform. So these types of disconnections are exactly what our real-time solution helps to detect and triage at scale. And we've put a 4-hour time here, so we use this as a threshold to decide when a meter is offline. So we can vary this to 1 hour or 2 hour, depending on how we want to optimize the system. So to summarize, smart meters can go offline for 2 reasons. The house on the top is working normally, so all data is going to the IoT platform. The second house has a loss of power, so this could be from maintenance or a storm like Storm Eowyn. And then the third line, and the second reason for loss of data is loss of mobile connectivity. So both of these disconnection types result in missing data and operational blind spots and potential billing issues for the customer and the utility provider. And without proactive monitoring, these devices can go dark for days or even weeks. So the challenge becomes, how do we monitor these exceptions in real time across millions of devices and act on them real fast? That's exactly where our solution comes in. So let's take a look at how we built it.
Yeah. So now that we have seen that the solution looks like from the user perspectives, let's go to into the engineering behind it. This section is all about the technical backbone, how we connected the IoT platform, streamed the data, enforced quality and security, and delivered it all in real time through the Databricks Lakehouse. We'll break down step by step, start with the push API logic app that enabled the event-driven ingestion from the smart meter platform, and it all starts with how we ingest the data. And so let's go there. So I would like to begin with the statement that the value of data lies not in its volume, but how quickly you can act on it. This sum up that what we are doing as a data professional, especially when we are dealing with IoT devices. We have billions of devices sending data, so it is no longer just about big data, it is about fast data. This is especially important in the energy sector where a smart meter constantly send data like usage pattern, fault signal, but the data is only useful if we can act on it quickly to detect the outage, balance the load, and improve the distribution. So here timing is everything, right? Timing is the critical factor. As a lead data engineer, I have been building a real-time analytics platform for smart meter data using Databricks. Today, we'll walk you through how we build this scalable low latency pipeline. So let's start with the push API. So I would like to explain you that what is push API basically by taking context of REST API. So here you can see that at the left-hand side, the REST API, where the client, like your analytical application or dashboard, has to ask for data, and server just wait and respond. This is fine for non-urgent data, but it introduces delay, especially if you are polling frequently. On the other end, push API flip that around. The server can proactively push data to the client. No need to wait for the request. It maintains the persistent connection using WebSockets or server event, depends on the application that you are using, which makes it ideal for the real-time scenario like IoT monitoring. For smart meter, this means that as soon as the readings or any alerts is generated, it can be sent directly to the processing system or UI without delay. This reduces latency, system overhead, and more importantly, enable faster and smarter decision making. Exactly what our use case demand. So the question arises that how you want to implement this push API. So that is where the logic app comes into picture. So initially, when I started working on this project, I was just aware of the REST API and the REST API clients and all these things. So, but clients were pressurizing us to use the push API, so we were not aware of it, that how to use it. So Porik and I discussed about it, that okay, let's go ahead with the Node.js and Java server, Java scripts and all these things, but you need a separate infrastructure for it. So we were looking for it, and then we came to know that Logic App can support it. So I'll tell you the benefit of Logic App, but before that, I want to highlight that if you look at the right-hand side, this push API implementation we have done with only 2 components. First component is the when a HTTP request received. As soon as you will receive this request, you will write a blob into the container. So that makes my point that this is a low-code solution, first thing, and you don't need any infrastructure for this because it is hosted on Azure, which is completely serverless. That is the benefit of it. And if it is Azure, then our entire ecosystem is Azure, so you can seamlessly integrate with the Azure ecosystem. It comes with the built-in security and compliance. You just need to put the signature in the request, and then it will authenticate automatically. It is scalable and reliable. As you can see, it is drag and drop. So apart from any technical person, non-technical person can also learn about it, and then he or she can implement it. It is cost efficient. We also taken care of the cost also. We are monitoring it at the real time. So I want to share my personal experience. It is just costing us $8 daily, so which is very less if you'll compare with the entire infrastructure that you need to build, like Node.js and firewall, and you need to take the IP addresses to support this. And the another thing that I like about Logic App is the built-in monitoring and logging. It will keep logging your messages and everything internally. That is the reason we chose the Logic App for the push API. Now we'll discuss about the data flow, how end-to-end data flow we have built for real-time analytics. So it starts with the IoT devices, where we are streaming the data continuously. So currently we are receiving 3 triggers per second. So you can assume that 3 files it is writing in every second. And then from there, it hits the Azure Logic App, and then which is act as an orchestrator. It captures the events and write down in the blob storage. And once the data is in blob storage, the Databricks take over. We use bronze, silver, gold. That is the standard medallion architecture. So in the bronze layer, we ingest the raw data with minimal transformation, mainly for the traceability and auditability. Then from there, as per the client demand, we kept the 15 minutes frequency update. And the silver layer, we load the data, the clean, deduplicated, and enriched data, like timestamp normalization or unit conversion. And in the gold layer, we aggregated data as per the client requirement, like daily energy usage, and Porik will share you what all the charts and KPI we build with the AI/BI dashboard. And finally, you can see that all these feeds are directly coming into the Databricks AI/BI dashboard, giving stakeholder the real-time action insight with minimum delay. This layered approach gives us performance, reusability, and clarity, and critical for the operating at scale. So this is just a glimpse of the low level, you can say, the structure. Now I will take you to the in-depth of the lakehouse architecture that we have implemented. So you can see it divided into multiple sections. At the source side, I clubbed the IoT and the Azure Logic App into single one. So you can see that is the first step, where we are receiving data into the blob storage. And from there, we are using autoloader, basically the DLT pipeline, to keep track of each file. So no need to manually track all these files. And from there, data flows into bronze, silver, and gold layer, as we discussed in manage through. You can see the access control over there, like it will check if a user is authorized to use the Delta Lake, or whether has credibility to access this layers or not. And at the core of this platform, we use the Unity catalog, handling the governance, access control, and the lineage tracking. This gives us full visibility into where data come from and how it transfer. and who is using it. All sits under the umbrella of data intelligence platform, which supports the workflow orchestration you can see at the top, which includes the CI/CD. And we put this data science and AI with Mosaic AI because we are expecting that client will give us future further use case like prediction of all these outages and all. So that's why that you can see that piece is blank, but we'll definitely going to put it in further use case. We are constantly in touch with the customer. So once this use case will be filled, it will be there, the components will be there. And it also support like SQL and BI tooling for analysis and dashboard. On the right-hand side, you can see the data consumer dashboard, like API and external partner consuming data to data sharing securely in real time. So here customer are asking us to share this data to third party also, like ESB. So for 3Island, ESB is the third party vendor. So for ESB also there are some third party vendor. So we use data sharing to share our data with the consumer. The key advantage here is that we have one unified platform for batch streaming and AI without traditional silos and duplication. So this is all about the architecture, but I would like to deep dive into the Delta Life table that we have used. So in our pipeline, Delta Life tables is the engine that power the bronze layer especially, where the Delta Life tables getting data from the blob storage at the real time. It connect seamlessly with the autoloader, enabling us continuously ingest data with zero manual tracking, as I mentioned. The best thing I like about the Delta Life table is the auto handle schema inference and evaluation. If there is any schema change, it will handle automatically. No need to manually change the schema or drop the table. It will automatically handle it, and there will be no failure of your pipeline. And another good thing that you can see that we can define the data quality checks. So it will ensure that required fields are present, values are within the expected range, and it will reroute the bad records into the quarantine table, and then we can work on it as per the requirement. And the pipeline code is also declarative, like you just need to declare some methods. You can directly use it as it is. So this is another advantage. This drastically reduced our operational overhead, improves the reliability, and give us robust and future-proof foundation for real-time analytics. So we decided to use Spark streaming also initially, but when we started using the Delta Life table, we figured out that it is much more easier than Spark streaming because you no need to mention the location that where you need to save the checks and all. And all this functionality will definitely help us. That's why we decided to use the Delta Life tables. Now, this is the final piece of our technical backbone. The data management is basically the core of any production grade pipeline. So we have built it around 3 key components. So first one, you can see the Unity catalog. Every table that we create is in bronze, silver, and gold registered and governed centrally with fine-grained access control, data lineage, and auditability. This gives us confidence that we can scale securely and meeting the compliance need. And the second part is the Databricks asset bundle. This allows us to deploy and manage our DLT pipelines, dashboard jobs through declarative YAML, making our entire setup reproducible and version control. This also enabled CI/CD for our data workload with consistent deployment across dev, test, and prod. Finally, this is the new thing. When we were working on this project, we came to know that Databricks launched this new data quality framework that is DQX. For Delta Life tables, we used the inbuilt data quality sticks, but for silver and gold layer, we started using this DQX. It runs as a part of data ingestion pipeline, validate the data in real time. It really helped us. It caused a batch record, malformed records, which they cause downstream issues. It help us to trust our data and move fast without breaking the pipeline. So our entire solution is based on this. So this is, I think, I've done with the technical thing. Now, Porik will walk you through the AI-BI dashboard, what customer is seeing actually. Yeah.
Okay, great. So we ingested, cleaned, and governed our data. Now let's take a quick look at how we visualized it using external tools and AI-BI dashboards directly in Databricks. So real-time information creates real-time knowledge, and real-time knowledge leads to real-time action. I love this quote from Mark Benioff because it captures exactly why we built the solution the way we did. Not just to move the data fast, but to help people respond fast with the right insights at the right time. So let's take a quick look at what that looks like in practice through our dashboards. So let's start with the external customer-facing view. This is what ESB and other utility clients see when they use our dashboards. This can be in any BI product depending on the client preference. It can be Tableau, Power BI, or Plotly, or any other dashboard solution. It provides both the live and historical insights on smart meter disconnections. On the left, we see a live count of devices not connected, updated in real time through our Databricks pipeline, and broken down visually by metrics such as how recently the device disconnected, and other metrics provided by the data in the packets from the push API. Then on the right, we see a log of recent disconnection events, including the metadata like the device ID and the timestamp. There's also access to historical data day by day, which helps with trend analysis and reporting, plus an option to download the data and for deeper offline investigation. The key here is accessibility. We've taken the complexity of real-time IoT monitoring and delivered it in a format that's actionable for field engineers and business users alike. So let's take a look at the internal dashboards we use within Databricks to monitor the platform itself. So in addition to the external customer-facing dashboards, we also built internal dashboards directly inside Databricks using AI/BI dashboards. And this gives us end-to-end visibility across the entire platform. So what are the benefits of using AI/BI dashboards? First of all, they're natively direct in Databricks, no integration required to connect to other systems. They're also incredibly easy to develop and maintain with the drag and drop canvas, or you can even use AI-generated prompts to generate the charts. It's also easy to slice and filter the data, no performance issues with the charts, even when you contain millions of rows. So we have a number of use cases for this IoT project. First of all, we simulate the customer view, so internal teams can see exactly what the clients will see. This enhances customer support or other data queries. We can also monitor the push API traffic, making sure events are flowing in. And we can also track the compute usage and DLT pipeline performance to manage the costs. Also, we can watch out for data quality violations flagged by the DQX rules. In short, these dashboards give us a single pane of glass, not just for the data itself, but for the health of the entire pipeline. So let's look at the first internal use case in more detail, simulating the customer view. This dashboard mirrors exactly what the external utility customer team see, showing the live disconnections data on the first tab. We can also get a breakdown of historical data on the second. And this allows for trend analysis over time. For our support and data teams, this is hugely valuable. It lets us validate the customer experience, test changes, and debug any discrepancies, all using the same visuals and filters that our clients rely on. This means faster support, better issue resolution, and a consistent understanding across all teams. Our second use case is about monitoring the stream itself, specifically the push API transactions coming from the IoT control center to our Azure Logic app. These two charts show the volume of events per hour and per day, giving us visibility to whether the data is flowing as expected and alerting us to any sudden drops or spikes in the volume. Having this live in our internal dashboard lets us catch problems early, validate ingestion rates, and reassure the stakeholders that we're seeing what we should be seeing. Our third use case, we can track the compute costs, particularly the DLT and serverless jobs, which can scale quickly. Here we have the compute costs broken down by day and by month and by job type. These charts help us to track the compute costs over time. We can compare against different jobs, and we also can monitor for unexpected spikes that might indicate an inefficient query or a cluster that's not performing well. It gives our engineering and finance teams the visibility they need to stay in control. Especially at this scale, we're operating where a few inefficient jobs can add up fast. So time to wrap up and give you our key takeaways. So our lessons learned on this project. First of all, you need to monitor your compute costs closely. We experimented with server and serverless compute. We optimized based on the user requirements and the cost. Second, logic apps were a great decision for this use case. The low-code implementation meant we could deliver fast without building custom ingestion services. But this comes with an extra cost premium, so it's important to consider that in the planning. Third, Delta Live tables really delivered. It simplified the real-time ingestion, handled schema changes smoothly, and gave us reliable orchestration without heavy engineering overload. Also, having the built-in quality checks and monitoring was a game changer. Tools like DQX allowed us to enforce the rules of ingestion and spot issues before they reach the dashboard that the users are using. And finally, centralized governance using Unity Catalog helped us meet both compliance and internal security requirements, especially important when dealing with the regulated utilities. To wrap things up, this project was about building a real-time pipeline from IoT smart meters to actionable dashboards. And here's what made it work. Azure Logic App gave us a robust, low-maintenance entry point for the push API events. It's fast, secure, and scalable. Databricks provided a powerful and unified platform for streaming, processing, and managing the data at scale. And with AI BI dashboards, we turned raw data into operational intelligence, accessible to customers and our internal teams alike. The final result, our customers can now access live insights into smart meter connectivity. This helps them identify the long-term issues, resolve billing anomalies, and they can improve their customer service with proactive, data-driven decisions. So this is just one example of how a modern lakehouse architecture can bring IoT data to life, from the edge to the executive dashboard. So with that, I'll say thank you, and we'll love to take your questions now, and we'll also be around after the session if you want to ask directly. Thank you.